I'd like to welcome Mauricio he's an assistant professor from Vrije University in Amsterdam. I'm sorry for mispronouncing anything I mispronounced. And I will turn it over to you to talk about engineering block-based languages.
Hello, everyone. Thanks for the introduction. Yes, so well, my name is Mauricio. I'm an assistant professor at the Vrije Universiteit in Amsterdam. And today I want to talk about how to engineer block-based languages, and more concretely, how to use block-based languages for domain-specific languages. Next slide, please. So basically, well, in this talk, we're going to talk a little bit about what these domain-specific languages are, what are language workbenches, how block-based environments are developed for DSLs. And concretely, I will focus in two tools, KOGI and Blockbench. And then finally, I will show some research directions. Next slide. Next one. Yes. OK, so programming languages. So, well, we use programming languages to communicate with computers, and we have been talking about JavaScript, TypeScript. So those are examples of general purpose programming languages. And they have some particular characteristics because, as we know, the community that uses these languages and that develops these languages is huge. And they can be used to implement all sorts of applications. So we can think about a finance application, also a healthcare application, whatever we can think about. But then we also have different types of programming languages, and those are called domain-specific languages, or DSLs. So usually DSLs are small programming languages that are focused on some particular domain. For instance, we can have a DSL for music that it's only expressive for defining something in the music domain. And of course, while we have less users, this also brings some benefits because users can use their domain language to express whatever they want to express. So this makes easier for people that do not have a technical background to express what they want to express. Of course, there is also a huge barrier here, and is that, well, maintaining and developing a domain-specific language is quite hard and expensive. So therefore, we have tools that facilitate this and that help you develop domain-specific languages. So those tools are the ones we have on the right-hand side. So those are called language workbenches. So these are some examples of the most common language workbenches that we can identify. And next slide, please. Next one. Yes. So language workbenches, in a way, are IDEs for developing programming languages. And with IDEs for developing programming languages, I mean, like, you can develop like the language, but also the IDE services for the language. So basically, you can define the syntax and the semantics of your language, plus the tooling to use your language. So for instance, here in the slide, we can see some examples of things that you can develop and that you develop when you are creating a new programming language or a domain-specific language. And next slide, please. And this is more or less like the context we are in. So we have domain-specific languages. We have tools for developing those languages. But now I was working like trying to understand, OK, so how can we develop block-based languages? And then I noticed that there are mainly 4 flavors in which you can develop a block-based language. So either by using TypeScript and well, mainly Blockly. Then we have grammars, where you can define your language using a grammar. But you can also define your language using blocks. So we have the block factory and also Blockbench that I will talk about it later. And another common approach was basically having an existing block-based environment and doing extensions to this. So all the details about all these different ways of developing block-based languages are available in this paper, where basically we conducted a systematic literature review, and we were trying to understand how block-based environments are being implemented out there. Next one, please. Yes. So now the first approach I want to talk about is KOGI. So KOGI is a tool that I developed in which I take context-free grammars, which is a common formalism for describing domain-specific languages. And those grammars are analyzed by KOGI, mainly doing one transformation. So we have the definition of a grammar that contains what the language is supposed to do. And then from that definition, what I do is a mapping into what I call a block-based environment AST. So that means that I have this generic representation where I capture the most essential elements of a block-based environment, and basically I try to map each element in my context-free grammar to generate a block-based environment. So this has some benefits, and one of the benefits it brings is that if you have a grammar, you are already having a textual notation. So most probably you have already implemented a type checker, an interpreter, or a compiler for your language. And with KOGI, you can take that grammar as an input, and KOGI will automatically generate a block-based environment. So the benefit here is that users or developers can obtain a block-based environment for free, and they can reuse all the other stuff like compiler, interpreters, and type checkers based on an existing source code base. So they don't have to re-implement everything, but they just have this block-based interface for free. Next slide, please. Yes, so this is more or less how the mapping works. So these are some examples of a context-free grammar. So for instance, where we have a resource, we said that a resource is defined by a string, and then we have curly braces, and then we can have one or many instances, right? So basically how this works with KOGI is that I identify these elements that are the instances, and well, I know that there can be many of them, and they are represented as a statement input. And if we look at an instance, so an instance follows a similar structure, but here we have reference to single elements. So these single elements are shown as holes in the block. And this is how the mapping works, essentially. And of course, we have some predefined values. So for instance, integer value, we know that this is going to be a number, so they are automatically translated into an integer block within the block-based environment. So these mappings between existing data types is done automatically, but of course, users can customize this in KOGI. Next slide, please. Yes, so that's the first approach. So basically, the first approach was to take an existing context-free grammar, and from that context-free grammar, we generate a block-based environment. The second approach that we presented together with Koen, and actually Koen is going to give a presentation of some particular details of this approach, is Blockly Bench. So with Blockly Bench, what we wanted was to extend the block factory, and basically, we made an extension in which we have the block editor, but we can also have different block-based editors for defining the different aspects of the language. So we can also generate and specify the toolbox editor based on existing blocks. So here we can use blocks to represent blocks. And then we can have a preview in the final editor of how the block-based environment is looking so far. So all the changes on the block editor are also visible in the final editor. So all those changes are propagated live. So you always have the latest version of your editor. And then we have the generator editor, where we can define also our code generator using blocks. So this is quite handy because then we have all the different elements here. And then we can also verify how the generated code looks like. And if there are some elements that needs to be improved, well, you can have everything in a single view. We are still working a bit on the visual aesthetics of the whole editor, because we feel like, okay, there are so many things. And that's something that we want to work also in the future to improve a little bit the look and feel of Blockly Bench. Next slide, please. Yes, so with this, it's already, well, some ideas and some stuff, some prototypes that we have developed, but still there are several things that we want to explore as well. So for instance, we have used Blockly mainly to create code, but we also want to explore, okay, how can we use the block metaphor to visualize code? So let's say we have a source code repository, and we want to maybe do some refactoring actions that maybe the block metaphor, it's quite useful for renaming or moving classes or packages from one project into another. So we want to see whether we can use blocks also as a refactoring tool and not only to write code. Also, we notice in these translations and in the mapping that sometimes dealing with expressions within the block metaphor, it's quite hard. So we thought, okay, what if we can have some sort of hybrid languages where we have the block-based representation, but for some concrete elements, we maybe use text. So for instance, for dealing with expressions, I think it's relatively straightforward to write them using just text rather than dragging and dropping some blocks from the toolbox or either using drop-down fields. Also, since we are focused on having these integrated into existing languages and fully fledged domain-specific languages, we want to offer runtime support. So for now, what we do is we have the block-based editor. We press a button, we get the code, and then we can just input that code into the compiler. But we want to integrate the runtime support also within the block-based environment. And that's also aligned with the error marking. So in the compiler or in the type checker, well, we get all those errors, but we are still not able to reflect those errors into the block-based environment. And what makes it harder here is that, well, we need to somehow communicate everything with the compiler back to the UI. So we still need to figure that out. Also, because we want to focus in a more generic setting where we can do this for any language. So there is like the meta programming part becomes a little bit more challenging. And finally, to improve the usability of block-based environments. So what we want to do mostly is to try to bring block-based environments into an industrial setting so that also companies can use it, and how we can make this like possible and not use blocks only for education, but also to use it in a more industrial settings. So this is also something that Koen will be talking about later today after the break. And next slide, please. Yes, so as a summary, so with KOGI and with Blockly Bench, what we want is to ease the implementation of block-based languages. So we don't want to have to compile into JavaScript or TypeScript or Python, but if you have your fully fledged implemented language, you can add this block metaphor on top of your existing implementation. So we do this either by using grammars with KOGI or by using blocks with Blockly Bench. And also, we want to increase the adoption of the block metaphor in industrial settings and for other applications than education. And also, with these two projects, what we wanted is to have a better integration with a specialized language technology like Language Workbench. Thank you so much. I don't know if there are any questions.
Awesome, thank you. Any questions in the room? I see someone approaching the mic. All right, we can start there.
Hey, thank you, Mauricio. This is a wonderful talk. I'm curious, what level of grammars does your system support for context-free grammars? Are they just like LALR1 grammars, or like what level of programming languages effectively can you do?
So basically, well, you can use any kind of grammar. So in this concretely example, and we have focused mostly on Rascal. So Rascal is the language workbench that we use to implement this. But for instance, one of the other approaches that we implemented was using Smalltalk. So we also made like a grammar definition for Smalltalk. So in the end, you can basically define any type of language you want using this approach. So as long as, for instance, in KOGI, as long as you're able to implement your language using Rascal, we are able to generate the block-based interface.
And could I ask a quick follow-up? Have you considered being able to consume like Yak formatted files or something like that, so that effectively if you had a Yak definition for a language, you could use the system with it? Or is that just too complicated and you don't want to worry about it?
Well, for now, we haven't looked into that direction, but indeed, that's something that we will also be interested in, because I mean, we know like Jack is like really powerful. So basically, well, with Rascal, what we can do is more or less similar, but indeed, that's something that we want to have in our agenda, especially because what I said. So we want to bring blocks into more industrial settings, and that companies and different applications can be used in a block-based setting. And also, I mean, that comes from the motivation that, for instance, I was working with Canon here in the Netherlands, and one of the limitations we had is like, okay, well, we want to bring some functionalities that are already in DSLs, but sometimes it's hard to express them like by text. So it's way easier if people are able to use blocks to write their programs.
Thank you.
All right, another question in the room. Becca?
You might have mentioned this and I just missed it, but what exactly is the output of KOGI? Are you getting like block definitions, generator definitions, toolboxes? Like what kind of content is output?
So from the grammar definition, what you obtain is a fully fledged block-based environment. So you get the toolbox and you get the blocks definition. So that's also that's why I mentioned that in the future research directions, we want to better integrate this toolbox with the compiler and with the backend, because for now it's a bit like, okay, you have the UI, but you have to do some tricks in order to being able to execute the code. So what I want to have is to have like this fully fledged block-based environment deployed after you just press like, okay, I want to KOGify my language.
Great. I see a question. Oh, Becca, do you have a follow-up there?
I do not have a follow-up. I have a second separate question, so I can wait.
Okay.
Perfect.
We'll do one virtual, then go back to you. Matthew Bishop asks, how do we learn more about Rascal? Is that right?
So if I understand the question correctly, is how do we learn more about Rascal?
Yes.
Yes. Okay. Well, so you can go to the website. So if I remember correctly, it's rascal-mpl.com. And if not, in one of the papers that I mentioned or that I had in my slides, you can find all the information. Or also, if you Google KOGI, then you will have the link to Rascal.
Great. Thank you. And back to Becca's second question.
So you talked a lot about this being used in like enterprise work settings. Do you see like any potential use for an educational case? Because I feel like a lot of educational applications do kind of have a domain-specific language. Like taking Scratch, for example, they have very particular programming concepts for manipulating sprites, or like if you're looking at like a logo kind of thing, like turtle functions. So do you think that there's an application here, or do you see it as completely separate?
I do see an application here, and actually, I don't know if you're familiar, for instance, with Hetty. So these programming languages for teaching children. So for instance, that programming language, they use something that they call gradual grammars. So I think it's very interesting to have like these gradual grammars and to offer a block-based interface for each of these steps, because basically they have like small subsets of the grammar depending on the level the children is in. And depending on that level, you can imagine that you can generate a block-based environment for each specific step or level in the grammar. So I do see also an application for education. And also, I think last year, it was one of the presentations was about a block-based environment for data science. So I think this also works for those kind of settings in education where maybe you want to teach, like, I don't know, biology or something like that, where you can define a grammar for your language and then you press a button and then you get the block-based representation. Actually, I even used the KOGI to make a small visualization of the different chapters of my thesis. And that was quite cool because I just wrote like chapters and sections, and basically I got a block-based representation for my thesis.
Awesome.
That is so cool. I love that. Thank you.